What's up, Chem class? It's Sadie. Today I'm going to tell you about the science of hair dye. There are many kinds of hair dye, including permanent, demi-permanent, semi-permanent, and temporary dye. Hair dye comes in all sorts of colors, ranging from more natural ones like dark brown and dirty blonde, to unnatural ones like hot pink or light blue. Today I'm going to be dyeing my hair 2 different shades of purple using 2 different brands of semi-permanent hair dye. While I dye my hair, I'm going to explain the chemical processes that occur during the production of the dyes and their components, as well as the reactions that take place once I'm actually dyeing my hair. Let's do this. The natural pigments in most organisms are caused by melanins, including hair. Melanin, a type of amino acid, attaches to a protein called keratin that your hair is made out of, and dictates the color and shade of your hair. Melanin is divided into 2 subgroups, eumelanin and pheomelanin. Eumelanin is generally more abundant in darker hair because it creates the range of hair colors from brown to black, while pheomelanin is more abundant in red hair. Blonde hair is caused by low pigmentation, and gray hair is a result of the body no longer producing pigment. Almost all permanent hair dyes contain 3 parts: hydrogen peroxide, which bleaches the hair, and the primary and secondary intermediates, also known as coupling agents, which react with one another to form the dye molecules. To begin the process, the hydrogen peroxide oxidizes the natural melanin pigments, removing the conjugated double bonds that create the color and leaving the molecules colorless. Often, ammonia is also used in this process because it swells the cuticle, making it easier for the colored dye molecules to pass through to the hair cortex. This part of the dyeing process also increases the pH of your hair because ammonia acts as an alkalizer. This shift towards overly alkaline hair can result in drier, more coarse hair. The primary intermediate acts as a reactant, and when paired with the coupling agent, aids in the production of the desired color as well as making the color last longer. PBD is a commonly used primary intermediate, but due to allergic reactions experienced by some people, alternatives such as p-aminophenol have been used in hair dyes more recently. The coupling agent dictates the color of the dye and can be categorized into 3 color groups: red, green, and blue. Within these 3 colors, there are clearly variations as seen in the countless colors advertised for hair dye. The primary difference between demi-permanent dye and permanent dye is that demi-permanent dyes don't contain concentrated ammonia. Although these alternatives to ammonia are safer, they aren't as good at lifting natural color, so they are generally only capable of darkening hair. In the Ion demi-permanent hair dye in Midnight Blue Black, the ethanolamine operates as the developer in place of the ammonia. It's formed by reacting aqueous ammonia with ethylene oxide, so although it's advertised as being better for hair, it still can be potentially damaging when used frequently. According to the International Journal of Toxicology, TEA, DEA, and MEA are safe for use in cosmetic formulations designed for discontinuous, brief use, followed by thorough rinsing from the surface of the skin. In products intended for prolonged contact with the skin, the concentration of ethanolamines should not exceed 5%. MEA should be used only in rinse-off products. The results of this study were later confirmed in 2015, with the conclusion that as long as hair is not being dyed constantly and is being rinsed properly after dyeing, that it's safe to use. I am not actually using this one right now, but I think that it's important to demonstrate the differences between semi-permanent and demi-permanent, because that's often kind of a gray area for people. Semi-permanent dye, which is what I'm using, uses primary intermediates and coupling agents like permanent and demi-permanent dye, but rather than using hydrogen peroxide or ammonia to pass into the hair cortex, semi-permanent dye buries dye molecules just beneath the surface of the hair shaft. This damages hair less, but means that the color doesn't last as long because the color molecules are dislodged relatively easily through shampooing. Temporary dye is extremely similar to semi-permanent dye, but is even less harsh on hair. Rather than the dye molecules entering the hair shaft, they're deposited on the surface, washing out after a couple of shampoos. So there you have it, the science of hair dye. Don't forget to like, comment, and subscribe. Bye!